So in part B, we are told to consider a scenario where the block travels in a circular path at a stretched distance of d. We need to determine an expression for the magnitude of the net force exerted on the block. And well, we've kind of already talked about this in part A, so we know the net force, firstly, is simply m times A. And well, we know here the net force in this case is only the spring force. So we can say this is simply the spring force, but we know that the spring force is related to the spring constant times the displacement. So in this case, maybe instead of k and x, we can use k and d, as d is the extension that we have, and we have m and k0 times d in this case. Then in part 2, we need to derive an expression for the tangential speed of the block. So what we know is that the net force we have here is simply, well, as we said, k0 times d. This is the only force that is acting. And since we have this force that is making an object go in a circle, and this force is always pointing towards the center of the circle, it is also the centripetal force, which has the formula mv squared over r. And so we can plug in our values. So we know k0 and d. We know our mass is m0, our speed will be v squared, and our distance is our length plus the d. So we need to consider the radius of the circle that the block is moving in. We can rearrange for v to find that this is the square root of k0 times d times l plus d divided by m0.